it will result in almost doubling the cattle population. It will also increase dramatically the number of pigs. And we know that agriculture is one of the biggest greenhouse emitters, and animal husbandry accounts for 80% of these emissions. And this doubling of productivity will result in doubling of the greenhouse emissions. And the greenhouse emissions will increase 105% compared to 2017. Therefore, the World Bank, which funds this project, one of our objectives is to achieve the zero balance in terms of carbon emissions. To this end, we suggest that we make the following steps. First of all, we suggest to have a number of activities to somehow boost the agricultural farming. So by means of boosting productivity, by means of increasing the feed of the cattle, by means of improving the activity of the vet oversight, we can reduce the cattle population, which will result in less greenhouse emissions, up to 62% compared to 2017. And the second way, the way which focuses on the soil, this is about the fixing of carbon on pastures using the CSA methods, and therefore the soil science may actually help us in calculating the territory needed in order to capture the carbon, soil, organic carbon, and also to premeditate certain activities to be done. Therefore, we are calculating a number of models for the territories which will compensate for that greenhouse emissions, and the territory of land which will be calculated will influence the further progress of the project. I'd like to draw another example of how soil science may help us in addressing the practical objectives, exemplified by another World Bank project called Agra Observatory. So this is how we process the agricultural and climate data in real time. This system is being implemented in Uzbekistan by means of winter wheat. And so the planting of winter wheat is almost over. Most of the wheat is at the stage of the early vegetation and soon will enter the tranquility phase. So this is the climate diagram on the slide showing that the number of amount of sedimentations or precipitations the amount of precipitations on that territory is almost normal, but as far as in Uzbekistan, they have a limitation in terms of the amount of moisture. We also looked not only at the big picture of Uzbekistan, but we looked at its different districts. In the southern regions, we may see that this blue line stands for the amount of precipitations, and this amount was either above the norm or equal to the norm, but in the north, the amount of precipitations, so this is the lowest figure, it was below the norm. We can make a conclusion proceeding only from the agricultural and climate data. And Above you may see the line of 2017, and therefore we may conclude that we have to draw attention to the climate conditions in that region back in 2017, meaning that probably something has been done by the municipal authorities or by the farmers themselves in order to avoid the consequences of the heat waves. But these climate data won't be interesting for the farmers themselves, but it would be rather interesting for the municipal authorities and for the investors in order to calculate the climate risks. But once we add the soil data to that model and the model of agricultural crops, different models of pests and diseases, in that case the soil science will make that information more accessible for farmers and more applicable for their everyday life. This is the end of my presentation with two specific examples which we can discuss of how soil science may be used in practice. Thank you so much. When we analyze precipitations on a specific field too, we have to assess the evaporation and perspiration, which depends the temperature and which would actually depend on the slope, on the curvature. Can we be guided by that averaged data without extra certification of the... Yes, actually the system works online using the grid 9 by 9 kilometers mesh. Therefore, we can use extra expositions and certain relief features, and once it is done, it would be more relevant. So, this is totally inapplicable to the Far Eastern territory. For instance, in Sakhalin, we took stock of the agricultural lands. I got a feeling, even I'm confident, that the agricultural lands depend on how we take stock of that. First of all, we have to take stock of the lands, we have to classify them, to register the rights, and only then this land can be used in the turnover between the farmer, between the state and the land user. The inventory of the lands has been done on different municipalities and other territorial entities to somehow take stock of the negative and detrimental processes. The idea of the inventory includes the data collection to know the quality and quantity of the land, to update the land users, indicating the boundaries of the lands, to redistribute the lands, to take decision on the territories which are not used, to set the boundaries of the municipal entities and changes there, to identify the processes which may have a detrimental effect on the state of the lands, to do mapping and to get the data to improve the tax revenues. The development of the forest has become a top priority for the state, because most of the lands there are not arable, are not tapped, and are not appropriate for life. The Far Eastern Hectare project was launched. Anyone can apply for that hectare online and any time of day, but due to the fact that certain documents were issued for the land plots there, and there are some land plots which have now boundaries and which were registered following the so-called country house amnesty, We are lacking the real data of the land use. The federal municipal authorities of the Russian Federation had no opportunity to take decisions on issuing the legal documents on those territories, and therefore the Sakhalin government needed badly the inventory or taking stock of the lands. We have developed the following technology to take stock of the agricultural lands, getting the archives from the Ministry of Agriculture of the Russian Federation, updating of the data, and getting the data from the mapping department and from the local authorities. In 1990s, these territories belonged to the collective farms, and the land use was quite active. After the 1990s, there was an outflow from the rural area, especially from Sakhalin, and a lot of data, some land plots, which were allocated to the people. They were taken by the local residents who fled from Sakhalin, and therefore these documents were not recorded by the local authorities. And there were cases when people will come showing the notary document saying that this land plot was allocated to them, and therefore the inventory of the land plot was needed badly. And actually the field works were organized, and the cartographic layout was done for 28 different districts of Sakhalin region, and therefore after that the data was included into the GIS of the entity. So the territory of Sakhalin is more than 87,000 kilometers. In order to make the orthophoto maps, a special joint project was launched in order to get the data, and the data were requested from the archives. So we used the archive maps which were before stored for about 2 years, and we ordered a land survey which was done within a month after that. The orthophoto map was done for several thousand kilometers. After that, we did the inventory of the territory in an automated mode. So it means that 30% of the work was done automatically, and actually 30% that was the manual work of the map designers. So we made a map with a scale of 5,000, 1 by 5,000. The digital maps which were received from the register were of poor quality, and therefore the executor had to get the information from to request the information from the Ministry of Defense. So the Ministry of Defense had 100% of the necessary data. I can only add that as far as this work was done for the sake of the local authority, for the federal authority, all the systems, all the software were used under the aegis of the import substitution, meaning that everything was Russian-made. We didn't use AutoCAD or MapInfo. We used the Russian software called Panorama, the Russian software. After, in order to issue the passports and certificates and to specify the boundaries, we did field studies. We studied every land plot identified there, especially the one which was used for agriculture. And some samples were collected and they were passed over to the drying shops. So this is how the drying was done. As a result, we got the necessary data for every land plot. We specified the boundaries, how it is being used, whether there are capital structures on that territory. We got the data about the land improvement negative processes, and whether actually this or that land plot can be attributed to the valuable land. So we took pictures of every land plot, and we also specified and updated the registration documents held by the residents. The samples of dry soil were then rendered to special labs for further chemical analysis of the soil. As a result, we got the following data: the type of the soil, the content of the organic ferments there, and for instance, the content of the labile phosphorus and exchangeable potassium. We identified acidity, acid value, then we also identified the density. All in all, we collected more than 130,000 samples there. After we analyzed the samples, so we have prepared a kind of a passport, the registration document for every land plot. These documents were then passed over to the government of Sakhalin, and the copy of that was sent for storage to the Russian register. All in all, we have prepared more than 37,000 of such documents, of such passports. After that, we have prepared the so-called data or digital layers. The digital layers were then converted into the GIS system of the Sakhalin region. As a result, the government of Sakhalin got a tool in order to manage their land resources, helping them to take decisions. The population of Sakhalin got an access to the coordinate grid, and where the land plots are located, the local authorities got the data about how the land plots are being used by different physical persons and legal entities, so that's improving the tax collection or tax revenue. And the local authorities will use this project in order to remedy the mistakes made during the registration of the land plots. There were numerous such mistakes and errors, and there were lots of land plots which were wrongly put on the map. In terms of the layers, let me suggest an overview of the green plantations in Moscow. The government of Moscow took a decision to set up a data system called the Register of Green Plantations. As of 2019, more than 6 million items of the green plantations have been taken stock of. And following the field study and the inventory, the green plantations will actually be introduced into a special register, identifying the age and the type of care it needs, etc. After the input of that data, we can update the data about the roads and paths and the greenery, something which is used for gentrifying, in order to be able to allocate necessary money to local entities to take care of the trees grown there. And at the moment, we also do some remote sensing of the trees and shrubs. We are using the microwave frequency wave technology to do that. So we're using specific microwave frequency wave which penetrates through the tree. We also are collecting the physiological properties such as the juice movement. So we are assigning ID numbers to every tree. A special data reader was developed which emanates the microwaves and then receives the data and records that. After that, the sensor will assign an ID number to every tree and would store that data. So the main idea of that project is to actually make a low-cost production of such sensors and the readers so that people responsible for taking stock of that work could do that cheaply. So at the moment we are using the Italian-made sensors. They actually are they're not resilient, they are very vulnerable and they're quite costly. And the chemical properties would be collected in future. Thank you so much. I didn't tell you about Sakhalin. I only scratched the surface. I didn't mention who helped us, who prevented us from working efficiently, something which was done all of a sudden. Just so yesterday we spoke about amendments to the Constitution. I just think that this is too premature. I think that we have to streamline everything at the level of the local authorities. Thank you so much. Should you have any questions, you're most welcome.
Yuri, thank you very much for a very rich presentation. Number of studies is impressive, but who helped you? Did you use this? Who did the soil analysis for you? Well, I have soil scientists, graduates of the Lomonosov Moscow State University, so they got very good knowledge at the university, and they did a good job. But you mentioned a huge number of samples you had to take. Who did the sampling? Okay, we had 10 teams, 3 individuals each. Well, those were not soil scientists. So those were hired staff. They traveled across all the districts. They collected soil samples, and they submitted the samples to our labs. And we dried the samples. We identified the density. We crushed the soil. We studied the soil in the lab environments by our soil scientists. Well, we failed to find adequate labs in Sakhalin, price-wise. There was just one lab available to us at the Regional Ministry of Agriculture, and they charged us some 3,500 rubles per sample. So since we had to deal with hundreds and hundreds of samples, the total cost would have been exorbitant. Besides, due to logistical constraints, we had to do. I wonder, this description of those districts, is it something that you did on your initiative? No. It was part of our terms of reference. This description of a passport was something that the region was needed. I was talking about the description. See, in our region, in Krasnodar, we have a somewhat different idea. We want to link the description of soils to the cadastre number. This would have been more rational, the way I see it. Well, we used the data contained in a uniform registration system. We wanted to see whether the land plot is abandoned or is in use. In fact, some land plots could not be split into parts, but after the break-up of all those collective farms, the land that used to be owned and operated by the collective farm was split into shares and allocated to the former collective farm members, and that was the end point first. The sensors on the trees, do they look at moisture or some other parameters? How precise those sensors are in full life? Well, their useful life is about 10 years without replacement. They costed 3,000 to 5,000 per sensor. Yeah, currently they cost about 5,000 rubles per piece, per sensor. In the future, the cost would be lower. Now, you did a lot of upfront work done for Sakhalin. I wonder if you did some expert appraisal of the materials that you obtained, because given the deadline of your exercise, yes, we did this. Well, thank you very much for your questions. In fact, our project on Sakhalin was arranged by the Ministry of Property, and interestingly enough, the local I will talk about a medium-sized analysis of agro-ecological conditions. We touched upon this topic yesterday somewhat, and the questions to the first speaker from the World Bank also were related to this issue. That was about decision-making process, and medium-scale data is well, this is a challenge. I mean, we lack this kind of information on soil, on agroecological features, and this makes it very difficult to introduce any new practices in agriculture. This also prevents new owners from obtaining information on what they actually own. This also brings about issues with land auctions and so on. Now, in order to employ intensive agriculture techniques, one has to look at the land resource in a broad sense and assess the resource. There should be some kind of a database that would describe all the features of such land, be it climatic data, climatic conditions, as we heard from the first presentation, or fertility classes for broad areas. Without such databases, it is next to impossible to do regional planning or spatial development. Government regulators would find it difficult to work at the subnational level. They would lack information and so on. Relevant and state-of-the-art data. Well, I'm talking about Russia, obviously, and CIS countries. In fact, and I think you all are quite familiar with the situation, if you want to get a regional map, soil map, you would be in a position to know when such map was produced, to where it is located now, whether it is available in a digital format or not. Moreover, for some regions, the quality of such maps would vary vastly. And in fact, modern agriculture, modern technologies cannot use such maps. Therefore, we have to resort to remote sensing. We have to bring in climatic data, and based on this, we have to come up with a new technology that would allow us to obtain some updated data, modern data on agroecological properties of specific areas, so that we could inform our decision-making processes. In order to create such a database, we are to understand what kind of information we need that will later help us identify specific land classes. Then we can go ahead and identify some land categories suitable to specific crops or to specific technologies. Besides, this might allow us to do better monitoring. We have so-called quasi-continuous monitoring. We can use drones, we can employ a network of sensors, we can do high-frequency sensing techniques. But in case you do not know what kind of properties your land has, it's next to impossible for you to understand whether your land gets better or whether its conditions deteriorate. This is especially relevant in case you want to compare two plots that are located far away from each other. Obviously, any attempt to employ modern technologies will have to rely on such data collected via drones, via sensors. But this kind of information normally would be very fragmented. I mean, some fields are covered by drones, some others are not. And this will not help you to produce a more comprehensive, more holistic picture. Well, back in the Soviet times, back in 1970s and 80s, there were some attempts to do this, but at that time the state of agriculture was totally different, and obviously the data collected back then cannot be considered relevant now. Well, we have accumulated tremendous amount of knowledge in terms of remote sensing application in agriculture. One problem, though, is as follows. We are to understand how to actually use the data we collect through remote sensing. If you take some satellite images, like a couple of images produced, say, by OneSat, well, those images would not give you a holistic picture. You won't be able to understand at which stage of technology you are now, what kind of processes you observe on a specific plot, and so on. However, remote sensing data reflect the state of landscapes and ecosystems, including systems created by humans. In fact, multispectral remote sensing data reflects the solar radiation absorption, and in fact, the data reflects different types of transformations that have to do with the use of the primary energy source, the sun. Now, the ability to do such transformations would be impacted by the landscape features, mesoclimatic conditions, and if you're able to use a multi-year series of images, you'll be able to identify some regularities, and these, in turn, would help you to come up with agroecological groups. Well, I don't want to spend too much time describing all the sequence presented on this slide. Suffice it to say that in our technology we use a lot of images covering certain periods, say 3 or 5 year periods. Let's say we take 30 images covering vegetation season, and we identify key factors, differentiating factors for all the images. On top of this, We use data from landscape models. We take into account slopes, exposure, and so on, hydrology. If the area is sufficiently big, we can come up with some climatic data, and we identify some invariants that can be traced through all the images and all the data. Now, this kind of work was supported by the Innovation Support Fund and was done in Uzbekistan, in Jizak region. Well, that's not the only example of this exercise. I just use it as a case. Now, we were supposed to do agroecological assessments of agricultural lands, and wanted to see to what extent the outcomes of our assessments would match the soil maps data. We also wanted to check the data that were collected over the period of 30 years. One final deliverable was to be a GIS system that might help understand how irrigation system worked and whether certain decisions made were appropriate. Now, we came up with some stationary conditions data. Despite the fact that the uses of those areas changed over time, we still were able to identify those stationary status for respective areas, and we identified 6 major agroecological conditions that describe the spatial differentiation that runs through all the data. Now, the same conditions can be identified also for the data sets collected back in the year 2000, that is 20 years ago. Now, this suggests that we can use this technology. We can look at multi-year composite databases to identify the agroecological differences that persist over long periods of time. And this might also help us identify and monitor changes in fertility. Now, we use the Landsat definition, 30 meters, and this allows us to even trace individual fields, or even within individual fields. And this data later could be employed in order to introduce intensive tillage techniques, because we're able to see how landscapes and conditions vary by field or even within one field. Okay, my time is almost up. In conclusion, I'd like to state the following. Previous speakers and the participants of the plenary session stressed that one huge issue we're all facing is lack of regional data. Even in instances where such data exist, the quality of data is poor, and it's impossible to trace and monitor information by field. Basically, this requires that we should be able to cover huge areas and collect huge amounts of data. Well, mapping teams can cover several thousands of hectares per year, and obviously this is not enough compared to the total land area that has to be covered by such assessments. Now, the technique we suggest was developed together with the Institute of Geography of the Russian Academy of Sciences, and this technique allows to identify those differences, and in fact it also helps to identify all the features needed for the use. I wonder if you are familiar with the techniques produced by the Dokuchayev Institutes. Yes, I'm familiar with them, and yes, we do cooperate. Good morning. First off, I want to focus on the soil spectroscopy. This is a very much in vogue approach used to diagnose the properties of different soils. Then I will tell you about machine learning. You know, machine learning is another buzzword which is linked to the AI development. You know, you are familiar with this concept to some extent. Sometimes you get a text message offering you a loan of 1,000 rubles, but you start wondering, why me? Why this amount? Well, that's something that computer decided to send to you based on machine learning. And finally, explanatory value of soil analysis. This is something we normally use in our regular work. Okay. A couple of weeks ago, I worked in Moldova. I worked with Professor Zhigao, and he told me that in Moldova they did agrochemical survey. They've been doing this since 1950s, and in 2015, in the course of illegal attempt to get the building of the agrochemical service, all the archives were destroyed. Well, unfortunately, 70 years of work were lost. Now, the DEMO Institute continues to provide services to farmers with respect to soil analysis, and they charge some $50 per sample. They use state standards to do the analysis, and not many farmers demand such service from them. Now, calculations in agriculture in terms of application of fertilizers and meliorants are based on lab tests and lab analysis, and correlation of the parameters with the actual field tests. And these outcomes tell us how the application of specific fertilizers may impact on specific crops and their yields. Now, the farmers can analyze only those parameters that can benefit his or her farm. And many companies believe that, it is possible to come up with a quick and dirty approach using some set of chemicals to test your soil, and very quickly you can identify whether phosphorus or nitrogen content is high or low, and so on. And this gives the farmer a pretty rough picture as to what kind of quantity of fertilizers should be applied, and this in turn optimizes costs. Okay, one example. To neutralize 1 centimole per kilo in 30 centimeters of soil, one has to apply 2 tons per hectare. So here are some rough calculations for you. Second case. 5 tons per hectare of corn. In order to get such yield, we have to apply some 35 kilos of PTO5. Now, if we want to increase the yield, we can apply less and we can save money on this. But in order to realize the savings, we are to test the soil. The cost may vary. In the UK, this is done free of charge. The same applies to the United States. Each farmer in respective state can submit a sample for analysis and lab tests. So the cost is either $0 or $3, well, up to $20 depending on the season. There are some private labs that charge $20. Now in South Africa, public labs charge $7, private labs charge $20. In Bulgaria, the cost is the same, $20. In Russia, Moscow State University charges $55, and private companies charge $80. In Moldova, the cost per sample is some $80 to $100. But look, you save $75 and you pay $100 to do the lab tests. Well, you know, you would have been better off if you were to apply the full amount, full quantity of fertilizers without having to pay for those lab tests. Well, we can try do some calculations, calculations on the back of the envelope, literally, that might help us understand how much we should apply. Now, very recently, we've seen a number of attempts to employ infrared spectroscopy. And here I refer to the work by Bender, who together with Banin did a lot of statistics for soil science, and they came up with an idea that some spectral features of soil could be related to fertility and specific fertility parameters. Now this work is ongoing, and a team at the Jerusalem University recently published a paper on cluster-based spectral models. They work all over the world. Recently, they started to produce maps based on spectroscopy data and so on. Now, the system matures. The database of spectroscopy features expands. The same applies to soil features database. Well, obviously, we also tried to be on par with the most recent developments, and here are some outcomes that were presented in the doctoral thesis of Listen, who is present here. Now, as to organic carbon, we can obtain some fairly good outcomes, and correlation ratio is 95% for humus, for dry burning, and this is for liquid oxidization. And thanks to the spectrum transformation and statistical analysis, we can obtain some fairly good outcomes, some predictions, as we call them. Those are not measures, these are predictions. But in case of such analysis, especially when values are low, sometimes we have some negative outcomes and negative values. Let's say soil can obtain -2% of organic carbon. Well, obviously it's impossible, and we know this. But this is where AI comes into play, and all the values that are negative would be translated into zeros.
And naturally that the data of the margin of the calibration are totally unpredictable. Where another recent work of our American colleagues who analyzed the spectral libraries of all the soils available in the United States, and the correlation would be less because this is a big volume of data. And as we see, by means of multiple regression, they get very interesting data, very interesting results. Can we get one slide back? Okay. Oh, too far away, okay. And as you see, 40% of carbon and the correlation of 83% is believed to be quite good. But again, if you resort to machine learning, you can achieve more realistic results and get even a higher correlation, and the error would be less. The error. So in that case it is 2.5%, and in the other case it is 3.5%. 3.5% of carbon, it might be either 0 or 7. So this is how the distribution looks like. So the accuracy of these data is far from ideal, although the artificial intelligence works well. Only these are artificial or AI-based assumptions. A whole system of equipment has been set up. AgroCare's lab, for instance, in the Netherlands, which supplies lab equipment and the field equipment in order to measure the spectral features of the soil. The calibration can be done right during fertilization, without paying attention to the soil properties, and they actually compare the recommendations on the implementation or application of phosphorus based on the spectroscopy results, and you may see that these recommendations are quite close to the lab investigation. And so these guys say that still 15 kilos of phosphorus has to be applied, and there is some difference between the lab data and the field data, but such recommendations, all in all, can be given without any analysis or without any survey, just knowing what crops you are growing, and most of the farmers live like that, or do like that. Second thing, the main problem of the machine learning is reduced to the fact that, first of all, we have to deal with the predictions rather than measurements. Similarly, this is not too important because still the recommendations would be based on the regression of the measurements and the impact effect, meaning that the regression works here and there, but there are some statistical errors. But the other problem is purely philosophical one. This is the fact that there is no explanation to the results which you obtain. In a lab, you may say that you have measured the extruded phosphorus, and the plants may somehow release the same amount of phosphorus. Why computer takes this or that decision is totally unexplainable. So a person applies for a bank loan and he's denied this loan and he cannot understand why. And the bank clerk would say that this is the computer, not me. And we do not know why. Probably you are too old, or you have an ache in your leg, or probably you're a pregnant woman, or anything like that. So no one knows why, but just the computer decides that you don't need this loan. The same is true of the computer which analyzes the spectrum of the soil and says that here you have to apply more phosphorus and here you have to apply more potassium. That's why they switched to the assessment based technologies. It doesn't make sense. These technologies are quite cheap. You spend several cents and you will get some results, but the quality of that result is totally unclear and probably would be even worse than the chemical evaluations. Such an estimate may be of some help to the farmers, but he will not understand the connection between the properties and the emissions, and due to, for instance, the nature of that approach, the computer algorithms would be totally undeniable. The broad implementation of the assessment analysis results in the decrease in the rate of measurements done by the labs and may result in the decrease of the number of labs which are doing such measurements. And finally, we may have a false impression of the conditions of the soil, how we have to take care of the soil and how to rehabilitate it. Thank you so much for your attention. Just this was the information to take note of.
Спасибо за доклад. Конечно, человечество все время будет искать.
Mankind would be seeking easier ways to understand soil. I have the following question. You have the so-called fork of comparison. You take some parameters pertinent to the soil. You compare the dry soil and the fertilized one, then probably in essence you can do the calibration for every specific soil, how the spectral parameters would be changed once you introduce plaster and organic fertilizers. Actually, in terms of plaster, it would be easier because actually the color would be changed. In other cases, the color is not changed so much, but still using spectral analysis you can identify that. And for instance, if we do that using some standardized soil, anyone, we will see that. But if we try to use these methods at some different soil, then the parameters would be totally... I have just a comment on what's been said. For instance, that the instruments show that there is a shortage of potassium, but when actually before the vegetation there is enough potassium, and during the vegetation actually there is a shortage of potassium. After harvesting again there is enough potassium. So can we update and fine-tune this system depending on the field? Yes, we have to update that every now and then, and this my presentation would be of practical nature and is different from the previous speakers because I would like to render a specific example as how we may address the problem of food security using innovative approaches. And as was said yesterday, this way will avoid certain problems such as loss of SLC. And there is another problem as to the accumulation of organic wastes subject to certain transformation so that they could be recycled. And these problems can be combined. And these organic wastes can be used in order to certain material which can later on be recycled. And therefore, we will improve the quality of the product and improve the soil condition. At the moment, Russia develops the industry which deals with the soy protein, which is being used by the food industry and which replaces some of the well-known products. And this is something which is planted in Kuban and in other regions. And when processing soybean protein, 1 ton of soybean feed translates into 160 kilos of soybean molasses, which contain a lot of nutrients, which later on can be used. And along with that, Russia sees the increase in the amount of the timber and lumber industry. Splinters or chips, wood chips, which according to our legislation cannot be burned, cannot be dumped. But using soybean molasses, we try to address 2 main problems, such as recycling or dumping of the wood chips, or the use of the molasses as an organic fertilizer. Why soybean molasses? This is an innovative product because getting that soybean molasses with the high content of peptides, it looks like a gel. And therefore it makes it more difficult to use that in future. Our partner, which provided that soybean molasses, it dries it, getting some dried powder, and then this dry powder can be easily used by any industry. Other companies, other industries which work in Russia and abroad will get soybean molasses after the spirits purging of the protein. And after that, our partner suggested to use water for the purge of the protein, which is much better than the spirits one because it doesn't contain alcohol. And after that nephilic drying, the whole pool of microorganisms contained in that soybean molasses remains the same and can regulate different processes. The composition of this soybean molasses looks very interesting. Apart from 25% of sugars, from mono sugars to starch, it also contains 41% of carbon, nitrogen, of different amino acids, more than 3%. So the ratio is 11, which is a very good ratio. And it also contains a big range of phosphorus and potassium microelements, and more than half of these compounds are water soluble, meaning that accessible to the plants. Contains a lot of sulfur because soybean accumulates lots of sulfur, and it is retained by that molasses. It contains copper, manganese, iron, the full range of microelements, and it doesn't contain plumbum or lead, etc., etc. Any other hazardous metals, heavy metals. When composting of wood chips, we used wood chips, because we thought that once we can do the composting of that tree, then the other wood chips could be composted even easier. When we did analysis, we got a result that these soybean molasses which were used, the content of anaerobic cellulites is 10 by a factor of 8, so a high content of these cells contained in that soybean molasses. So we made a simulation when we did the composting of wood chips using water. Using a special solution, we used the soybean molasses, and we used the molasses of the solution, so we got the following data. The composting of wood chips was done better when actually we had the water-soluble approach. And on the left-hand side, so once you use water along with the sawdust, they look lighter. On the right, you can see the sawdust, actually, which was treated with nutrients and with water. So they contain more nutrients, they contain more microelements. And later on, actually, we will make a vegetation experiment, because the sawdust will be applied to the soil in order to this way recycle them and increase the content of the SOC. We did a vegetation experiment with barley. We applied those pre-composted sawdust. We applied nitrogen, ammonia, in order to improve the ratio. And so we introduced 7.7 grams of sawdust per 1 kilo of soil, and we got the harvest, the yield, which showed that once you apply sawdust being composed by the soybean molasses, you will see a material increase in the barley yield, and compared to the original data, the yield increases 2.5 times. And we concluded that we increase the yield, we increase the concentration of the content of SOC in the soil, although it is not dramatic, but 0.4%, which we announced yesterday actually, we reach this figure even more. And in another area, where we used soybean molasses, we used that as an organic fertilizer. Therefore, we made a vegetation experiment on our usual ash clay soil. Barley and pea were used, and we harvested the yield, and we followed the scheme where we had the controlling option, where nothing was introduced to the soil. There was an option where we applied soybean molasses, 0.1 gram per 1 kilo of soil. And this is about 300 kilos per 1 hectare. We used ammonia, which contained the same amount of active components, and in the fourth option we combined the organic components and non-organic nitrogen, 50-50 ratio. This is the experiment which we did. And we got the following results. The biomass of pea and biomass of barley increased dramatically once you applied soybean molasses into the soil, even compared to the regular ammonia-based fertilizers. And so the biomass of pea increased 70%, and the biomass of barley increased 60%. And in essence, the weight of pea increased dramatically. It was also noted that we increased the amount of SOC in the soil compared to the controlling group. That system of using the wastes, including the soybean molasses, fits very well with the organic farming. When we apply only organic components to the soil, the ones which contain no chemical compounds, compared to the traditional organic fertilizers, soy molasses has a lot of advantages. if we compare that to the manure, for instance, of the cattle, then soybean molasses, unlike manure, doesn't contain any pathogens, any thermophils, and other pests which are typical of manure. No helminths, eggs, unlike the cattle manure. No seeds, no typical odor, doesn't require any processing or treatment, and after you get that soybean molasses, it can be introduced immediately to the soil, unlike other wastes which can be applied to soil as an organic fertilizer. Thank you so much. Thank you. Let's thank Ms. Good afternoon. As a representative of a chemical company and agriculture at the same time, I have two questions. We have our own farms. How do you suggest to apply or introduce the soybean molasses? Because very often the organic fertilizers would not be introduced for economic reasons. It is not profitable, but as a producer of organic fertilizers, do you think that we can combine non-organic, for instance, ammonia-based fertilizers with organic? Back in Moscow State University, we tried to combine organic and non-organic components. There are lots of molasses in Russia, but actually produced by our partner called Renda. They dry that out. This is a powder. He asked as to it would be actually more convenient to apply that if they use capsules, so the granules can be applied. It is not fully water solvable. It is very difficult to be applied in a liquid form. Just so you can apply that as you do with the non-organic fertilizers. It can be mixed with other non-organic fertilizers if the need is. For instance, boron acid actually can be used along with the molasses, and probably you can get new. What is the hazard grade? So we did the feed testing, and it showed that molasses is attributable to grade 5, so it is not hazardous to the environment because there is no growth inhibition. On the contrary, and we saw that the roots extended by more than 20%. If we speak about the hazard grades, there are 5 types of hazards, and so this is grade 5. Anyway, you will have to get such a document because you will have to do the hyperbionts testing, otherwise you will not be allowed to introduce that to the soil. I am studying molasses in terms of my scientific research, and so this document, this is not my problem. You spoke about recycling of sawdust. I don't understand what you do because there are technologies of making briquettes actually which can be used as fuel. I have another question. Do you have any feasibility study of your technology so that you could compare whether your approach is more economically optimal?
Well, we've not done this assessment yet. In fact, this is what economists should do and not soil scientists. However, in terms of applying organic substance, well, the producer of molasses should dispose of it, and this requires a lot of money and a lot of effort. And if the company is able to produce a product that would be demanded in agriculture, well, the product will be bought by the end users. For farms, this would mean affordable organic fertilizer. All other types of fertilizers require sophisticated logistics, time, and money. As to sawdust, well, of course, some pressed boards are produced out of sawdust, but there are some companies that find it easier to compost sawdust rather than use sawdust as inputs for pressed board production. But again, it all boils down to logistics. Thank you very much. Good morning, distinguished colleagues. Just to follow up on our yesterday's discussion about a gap between the theory and the practice in soil science, I want to report the following. Well, apart from soil scientists, we have soil users. We have about 20 million small farmers, and they have to have good recommendations as to how to use their land, and this is what soil scientists are supposed to produce. So my presentation will deal with the economics of dissemination of such technologies and how these technologies and ideas could be brought down to people working the land. Now, the key issue is as follows. On the one hand, farmers do not get a full set of recommendations and process maps and expert assessments from soil scientists. Farmers cannot do this on their own. It's prohibitive in terms of cost and time. On the other hand, soil scientists sometimes are unable to deliver the products of their research to farmers. And very often I hear from colleagues that, again, they're doing everything wrong. Now, this gap, this barrier does exist, and I want to tell you about the approaches that might help us bridge the gap. I will use the case of Germany, and I will be speaking about organic agriculture. This is because such technologies help keep the properties of soil more than any other approach. We can speak a lot about organic agriculture, about how good it is. We can speak about sustainable agriculture, but unless farmers have sufficient incentives, unless the 20 million of small farms have specific market-based incentives, it is unlikely that we will see a lot of organic agriculture. So instead, every decade will be stating that the situation continues to deteriorate. Now, in Germany, about 10% of the total state support is provided for environmental measures, and the total amount is about 600 euros per hectare. We looked at about 90 hectares in the course of our study, and here are the types of subsidies and items that are subsidized and supported, thus providing incentives for environmentally friendly activities. If soil scientists would like to encourage some behavior or some activities, they could try to include those in respective laws. And they could try to make such measures eligibility criteria. In fact, the support in Germany is provided to all the farmers across the board, and not just some specific target groups. the state support is transparent, it is mass scale, it is not very difficult to obtain. There are some specific economic incentives. Some Russian regions also try to introduce additional incentives to promote and encourage organic agriculture. Recently, the Voronezh region hosted a conference on organic agriculture, and they launched a major effort to do certification and providing advice and so on. Now, a few words about the so-called ecosystem of organic agriculture in Germany. Now, in Germany, they host the largest organic agriculture fair, BAFAG. This is a huge event. People come from all over the world. It's a huge networking opportunity. There are lots of demo sites. There are people who deal with sales, who provide technology. I mean, the ultimate focus of this whole event is to encourage the development and spread of organic agriculture. Now, the support is mass spread. When I visited farms, I realized that students, even high school students, very often get engaged in activities that aim to develop organic agricultural skills. Back in the Soviet times, we had colleges, a network of colleges. We still have those, but they mostly produce specialists who later would be employed in industry, industrial companies. However, in Germany, colleges very often help acquire skills that would be required in agriculture. Students work at specific farms for 3 years. They work there, they go through all stages, and once a week they attend classes. So they use a reverse model, reverse to what we have. Instead of purely academic sessions, they acquire hands-on skills and knowledge. And Kassel University has a department dealing with organic agriculture. The Kassel University, as I said, has this department. And in fact, people working German farms, in fact, are graduates of this university. We do not have such a university or even a department at the university that would develop necessary professionals. Now, a land accounting system is in place in Germany. Now, one day I approached a farmer and I asked him to show me all his land and which spots are owned, which spots are leased. And he said, okay. 5 a.m. next day, he approached me. He brought me to the computer, a huge MacBook, and he switches on the system. In fact, the software package is provided by the government of Bavaria, and immediately I could see all the maps online, all the changes in the land composition. So basically what we saw is economies of scale. Instead of each farmer having to buy such a system on his own, the government provides such a system for all the farmers. Besides, it's very useful for the regulators. You know, when you provide your subsidies, you're able to trace which crops are cultivated and how the use patterns change. This is a very easy to use and easy to access tool. You don't have to be a rocket scientist. I mean, every farmer can use this system. It's very user-friendly. Now, how to disseminate best practices, how to make these available to farmers. In Germany, they deployed a network of demo farms. In fact, this is the second stage of this effort. The first one took place some 3 years ago. some 10,000 activities helped establish more than 200 demo farms. And last summer, there was an extra round of applications. So this is a huge networking effort, horizontal networking effort. It's not just that somebody hears about organic farming. No, people are able to come to such a demo farm and get some hands-on experience. Besides, you cannot train just farmers, just producers, because you have to deal with processing and with retailers. You got to work with those who sell the produce. I mean, if farmers are not able to sell their products, they would not be interested in producing respective stuff. Yesterday, we went to this field trip. An agronomist delivered a brief presentation to us. And in fact, we heard from him that there was no distinction between organic products, bioproducts. All the investments in certification would yield nothing unless we get a clear-cut distinction between the two. Agronomist yesterday said that he was not able to obtain a go-ahead from the farm owner to apply fertilizers. Well, the company we visited yesterday is pretty big, yet decision-making process is not streamlined. Information support is inadequate. The agronomist cannot substantiate and justify his point, and besides, he has nowhere to go to upgrade his skills. Now, in Germany, all people who deal with certification were trained in the same country. And they aim to dramatically expand the sector of organic agriculture. They have specific tasks and specific objectives. They're not after doing some tests or writing articles or books. No, soil scientists in Germany in fact disseminate their knowledge. They do a lot of extension. Otherwise, the efficiency of soil science would be very low. An action plan is needed to disseminate this knowledge. Well, I mentioned the demo farms. I mentioned the horizontal network for knowledge sharing and exchange. Well, I talked about Germany only, but altogether we can speak about a global effort to establish such demo sites. You can pick a farm in a region that you want to have a look at. You can have a look at specific crops, at specific animal breeds. You can pick a focus. You can volunteer to come to the farm and see everything with your own eyes. Back to the Kassel University that produces organic agriculture specialists. The student body is about 1,200 students. They deliver bachelor's and master's programs in German and in English. They host what they call the Eco Field Day, where students actually go to the field and get hands-on experience with respective activities. The students are welcome at the farms. There are some programs that are supported by NGOs, by private companies, and people can avail of those programs. And I think this is a good opportunity for soil scientists, for soil science departments to partner with those programs. Besides, soil science departments could also pilot some of those those approaches could develop such demo sites, and besides, this could serve as an additional source of revenues. Zapholter in Germany set up 2 demo sites, and he realized that the demand was huge. People were willing to come, they're willing to pay. And this knowledge transfer helped disseminate a broad range of technologies and techniques. So I think that this is a kind of model we could mimic in Russia. We could try to implement our technologies and our approaches using the same model. Well, I have several other examples to show, but I think I made my point. There is an ecosystem around organic agriculture. We understand how it operates, and we just have to bridge those gaps between soil science and farmers. And farmers should be able to implement respective technologies, and scientists should be able to deliver the outcomes of their research to farmers in an easy to understand and easy to use format. Thank you, Artur. After your specific question, I wonder, what's the difference between... Well, it depends on the products. The markup may be quite different. I visited a grain producing farm. Now, biodynamic grain commanded the price. It was twice as high as the price for regular grain. In Armenia, the situation is somewhat different. For instance, for horticulture, in Armenia, farmers get only 10 to 15% markup in terms of price, but productivity yield drops by 70%. So it's not worth for Armenian farmers to move into the organic segment. The National Organic Union came up with a report on the Tomsk region, and the margin there, depending on the crop, varies. I work at the Agro Support Division. Our customers are farmers, business persons. The ultimate objective is to boost the efficiency of their production. My objective is to increase revenues per hectare. However, my objective as a soil scientist is to achieve this without depleting soil. Now, the FAO sets exactly the same objective. Here we go. We are to produce more and better food while reducing pressure on environment. Now, what fertilizers can do to help achieve this objective? Well, in order to produce better food, we impact plants, we impact physiological processes. In order to reduce pressure on environment, we can reduce consumption of water per unit of area. This is a very relevant issue as of today. And we also can try to reduce negative impact on soil. I don't think I should go into detail talking about plants and water. I'd rather focus on soil. Now, the soil resources conditions on the world, published recently, outlined 10 key threats. 5 out of 10 can be impacted by fertilizers. Now, compaction, threat number 1. With respect to fertilizers, compaction means the number of runs that the machines make on the field. Now, we can do fertigation in order to avoid compaction. Well, obviously not all crops would be appropriate for this, but we could apply fertilizers via drops. Second, we can do leaf feeding dressing, and this dressing can be combined with herbicide application. again, this helps reduce pressure on soil. The next threat is acidification. I used both green and red colors to indicate this problem. The next issue is pollution or contamination. This is perhaps the most relevant threat. There are three factors related to fertilizer contamination. First is uneven application. To address this, we can do the following. The uneven application may be a result of the fact that the mixes comprise different sized granulars. Second, the fertilizer is not granulated at all. To address this issue, we can apply NPK fertilizers. As to potassium chloride, we can develop respective mixes so that the application is even. It was very difficult to achieve from a technology standpoint. We had to add some phosphorus, and we obtained PKP55 in the end. And finally, differentiated application is a good thing, but not always farms possess necessary machinery to do this. Not all can afford this. There are more affordable ways. For instance, regular silicon rags can be purchased, and they could be put in the field. And you use a regular app on your smartphone. You take pictures of those rags, and a program calculates the settings for your machinery. This is something that anybody can afford. And one last approach is sort of measures that help fertilizers stay easy to apply. Now, another threat has to do with eutrophication of water bodies due to runoffs from the fields. Biota uses phosphates and nitrogen. As phosphates do not permeate the profile, nitrates can permeate, and we can limit nitrogen application. There are some nitrification inhibitors out there that, in fact, stall the transformation into nitrates. Now, the nitrates can, the ammonia, that can very quickly transform into ammonia and bleached then, while is arrested, and this allows the plant to use up all the nitrogen gradually without accumulating too much nitrates. And finally, ballast substances, another contamination factor. As a colleague suggested, some agrochemical analysis of soils should be done before the feeding system for plants is installed, and some components should be eliminated. We all know how excessive chlorine or nitrogen could be for the plants. To granulate ammonia, it has to be warmed up or heated, but uret inhibits plants only if we apply more than 3% into soil, and we apply more than 1% onto the leaves. Now, our company has a separate line to produce low biuret carbamide with a content of under 0.8%. Now this is what we can do to address contamination. Now, loss of organic carbon. Organic fertilizers is a very relevant topic today. They are either not applied or applied insufficiently, yet organic fertilizers are needed. Unfortunately, we cannot force farmers to do this. We can only recommend that they apply those fertilizers. The only thing we can do is to add nitrogen into soil to help generate more organic carbon. That's perhaps the best we can do, although the losses are huge. The losses of fertility are huge. And imbalance of nutrients, another threat. I think this is something that we should focus on. We should come up with a balance that would be appropriate. We keep saying that each case is unique. And soil is a body that is unique in every single spot. Now we have water-soluble fertilizer, 9 varieties of the same fertilizer, high potassium, high phosphorus, and so on. You don't have to memorize this picture now. We used to have 9 brands, and we still had to create a 10th one because we got a customer who needed some fertilizers for urban soils, and he asked us to come up with equal wheat brands, and we had 3 of those brands. But then some specific soil properties came into play. Now the application would be on surface, which means that the brands that used ammonia would not be appropriate. And if we eliminate those, we are left with 1 brand only. But urban soils, in Moscow for instance, uses some ice melting agents in winter. And therefore the balance of magnesium and potassium changes dramatically, so we have to add magnesium, and this brand did not contain sufficient magnesium. We didn't have enough space for it, so we had to bring down the share of micro elements to add magnesium, and we had to remove copper, because copper in urban soils is not something which is welcome. In fact, it's a pollutant or contaminant. Now, the reason I'm mentioning all this is because I want to rivet your attention to what we as fertilizer producers can do in order to reduce the pressure on soil. Unfortunately, we are not omnipotent, so I call upon you. Please help us. I got a question to you. What else we could do in order to address this? Because we are actually a linking pin between science and the industry. We can speak to both parts of the equation. So thank you very much.
I just think that today we already spoke about the environmental documents or passports, and the passport which would be adopted for some specific conditions for the specific region, so that it could reflect the soil properties and the fertilizers which are being used. And thank you so much. I would recommend to you to use organic and mineral fertilizers, because organic fertilizers can be granulized very well, and both things would be very useful for the soils. As our colleague from Eurochem said, if I'm not mistaken, probably some other person said, there are some studies done to include organic to combine the organic fertilizers and mineral ones, but organic fertilizers are more sophisticated than the mineral ones. Yes, please. Organic fertilizers are not welcome in terms that it contains seeds, certain bacteria. And that's why they have to be thermally treated. After that, they might be used as a fertilizer and for the purposes of granulation of other non-organic